Hi, welcome to Mailbag Monday, everyone's favourite segment. And yes, this one is actually released on a Monday, or at least Sydney time, so no complaining that it's Sunday or whatever where you are. It's Monday here in Sydney, jeez. Anyway, look, we're overflowing again with mailbag items, so thank you for everyone who sent them in. I won't be able to get through them all. I've got like 5 postcards as well or something. So let's get right into it. Oh, by the way, everyone liked this background thing and me opening them on camera. I got almost 0 people who said, well, like 1 or 2, I think, who said that they preferred the older format. So, hey, I'm going to stick with this new format. Let's go. Okay, first package comes from Frankie Tong, and some people may be familiar with Frankie. He is I Love Electronics on the forum, but not only that, he is also the guy who sourced and supplied these beautiful gold-plated binding posts I use on the microcurrent, and he's got an eBay store, and he sells a whole bunch of stuff and supports it on the forum. So check out, I'll put in a link to Frankie's eBay store down below, so check it out if you're after cheap parts and meters and all sorts of stuff direct from Hong Kong. Frankie's your man. And also, I've had a lot of people complain during the mailbag segment about the knife I use to open my packages and how wimpy it is. Well, this is the Victorinox Mini Champ. It's my everyday carry knife. I love it. It's tiny, compact, it's got everything in there I need on an everyday basis. Fits in the pocket really well, but I agree. Okay, fine. That's not a knife. That's a knife. Yeah. Let's open Frankie's package, shall we? No problem whatsoever. Works like a dream. All right, let's go. What's Frankie sent? Woohoo! It's a multimeter. And here I was thinking he'd sent me a new multimeter, because he does sell new multimeters, Bryman and Unity and other brands as well. But no, he's sent me a vintage one. Awesome. And I thought you'd sent a Chinese-made DMM. I've done several ex-Soviet DMMs. Yeah, I don't think I've ever torn down a vintage Chinese multimeter. So let's take a look. It's the BRRI seal. He bought it, new old stock, Beijing Radio Research Institute, which doesn't exist anymore. All right, and it's apparently very fluke-like. Woohoo! Let's have a look. Thanks, Frankie. And of course, it's the A model. Couldn't afford to reprint the box. Oh goodness. Let's check this out. Manual, operating manual. Hey, there you go. It's not in Chinese. Look at that. Wow. Specs, yeah, 0.5%. Just pretty crusty stuff. Just your typical 3.5-digit DMM by the looks of it. Let's check it out. Oh, yes, it is very fluke-like. It's got the old fluke side style buttons. Ah, classic. And wow, what the hell probes are they? Not shrouded. You've got some weird ass 2-part molding thing on there, and these are just weird. Where's the finger guard? It's like, oh, slide off. Oh man, they're just weird. So yeah, classic side switch arrangement, cloning the Fluke 8020, of course, and other models. So what's coupling? I don't know what that is. That's rather weird. It's on the AC mode, so is that like an output function? And they, by output I mean, that's the old analog multimeter term for having an AC coupled input. But you sort of do that and it disconnects it. I don't know. Continuity tester? Not a latching one, but yeah, pretty quick. Instantaneous. And of course a crap transistor tester. It's the hallmark of a cheap-ass multimeter. Oh, I hate that function. And one of the problems with the transistor tester, look, exposed metal pins here, you've got to wonder, are they connected to are they isolated from the inputs here? Probably not. So you could easily, holding this thing, have your fingers on there and maybe be probing something. I don't know, maybe not. But anyway, it's in theory possible. You've got exposed metal there. So, fail. Yep, look at that. You got like 10 ohms between common and the emitter for the NPN up here, and it's just, it's just not great. I mean, there goes all your various safety ratings. Not that this thing would have any. You basically wouldn't be able to get a safety rating with a transistor tester on it these days. But hey, it's not entirely crap. I mean, I've seen a lot worse, and that LCD, by the way, is very big and clear, and it's got good angle on it, and it feels okay. So on the outside, it's not that bad. I don't know what vintage it is. We'll find out when we open it, I guess. All right, here we go. I'll lift the lid. Hey, look at that. 2-board construction. It's got shielding. Kind of surprised at that. And there you go. Look at that, hand-taped board artwork, of course. And there you have it. That's basically, what you expected from maybe, an 80s vintage meter or something like that. If we can get a look at a date code on that 8-pin dip there, then we might be in luck. Check that out. That's really interesting. It's got a, it's not bad. I don't mind at all. The angled support there for keeping that LCD at a specific angle, and they've socketed the chip on the back. It's just going to be a an intercell chipset, single chipset like that, and that's a bit how you're doing, just wiring that stuff over there like that. But I mean, everything, basically all the multimeter functionality is pretty much on the top board there, and the rest of it is just sort of all your input circuitry and miscellaneous. There we go, that's a TL062 dual op amp there, and it's just got 948, and what's that, EB, so that's not quite a date code. That's not your typical 4-digit date code, unfortunately. Let's try the LCD chip, or the main multimeter chip. Aha, no surprises, ICL 7106. Yep, that was the chip used in every 3.5-digit multimeter on the planet around that age. But look at this, this is a 90s vintage. There we go, the 20th week 1990. They were still manufacturing this thing. Jeez, that's, yeah, this has all the feel of it was definitely designed and sold in the 80s, that's for sure. And there you go, that's quite nice. The PCB designer was thinking, look, they actually made this as a panel like that, and you can see the breakout tabs there and there on the top of the board, and they manufactured that as a panel. Very nice indeed. And then it just flips up like that. Shame it's, they didn't use like a nice tidy ribbon cable on there or something like that. But what else have we got there? We've got a 4030 series CMOS and an op amp, and basically not much else. What's that? That's probably the external, no, emitter base collector. There you go. So that's a transistor. And well, that's all she wrote. That's all that's in a 3.5-digit multimeter of these era. And of course the ganged switches, they actually look and feel quite okay. I don't mind that at all. So this isn't too bad for the era. You're not going to get all the requisite input protection you get these days, because the standards are much higher. There's our 10 amp, is it 10 amps current shunt? Yeah, 10 amp current shunt there. A little bit crusty. They've just trimmed it there to value, but yeah, I expected a lot worse. That's actually not that bad, I guess. And that's an interesting mounting arrangement for the piezo transducer there. If you've got the board area, it's not a bad way to do it, actually. A big cutout on the bottom, and then just a couple of tabs on the side to solder on directly to there, and then just wire off a single wire. It's better. I think that's better and more elegant than having your traditional 2 wires, just coming off like this and flapping out in the breeze and wired through to your back panel. Of course, it's not as good as mounting it on the back panel, having the springs come up, things like that. But if you're going to wire it to the board or have it permanently mounted to the board, that's not a bad way to do it. And a couple of trimmers down in there. There we go. And they've put some sealant on those. So, yeah, somebody's got themselves at the right tongue angle there and tweaked those. So, yeah, but it's only a typical, 0.5% meter. So, nothing flash. And you can forget any HRC fuses, just then M205 glass type there. So, as I said, doesn't really meet today's safety standards. We've got input protection resistors, but that's about as far as it goes. There's no MOVs or PTCs. Now, that's interesting. Look at that. They're just taped over sort of like 5 individual traces over there instead of doing it in one big fat trace. Why? Sort of, you know, staggered fusing capability or something like that. This is for the current shunt resistors, so yeah, that's unusual. And somebody's had a hack at that one. There we go. That's an aftermarket mod. There's actually a piggybacked resistor on another resistor, so they couldn't even be bothered to suck it out. They just soldered it straight on top. And there it is, just bodged in down there. Oh, how you doing? So that does kind of suck, I guess, but, well, I've seen a lot worse. Thanks, Frankie. Very interesting. Next cab off the rank, addressed to that crazy Aussie bloke, from No Name. So, heck, let's check it out. Alright, let's go. Look at that. Just slices straight through. Oh, beauty. And we have a book. Here we go. Amazon 10 Essential Skills for Electrical Engineers. I was teed up about this one. I had forgotten about that. Let's check it out. Ooh. How to design circuits. Looks pretty good. Let's go. And if it's got a Swiss Army knife on the front, you know I'm going to like it. But hey, is that a Wenger or is that a Victorinox? And it's got a choke. Look at that. Good on you, Barry L. Door with 2 R's. It's part of the IEEE press done by Wiley. And let's take a squiz. Well, let's go to the blurb on the back. In today's competitive marketplace, engineering students and professionals need every advantage to succeed in job interviews and in the industry. This insightful book will serve as a valuable reference for them throughout the interview process and while on the job. Interesting. Okay. 10 Essential Skills applies the fundamentals learned in school to the practical tasks required by employers. Awesome. With the ultimate goal of helping readers land a job and succeed at it. Excellent. Insightful chapters that teach them how to design resistive circuits, prevent thermal failures. Awesome. Analyze circuits, use stats to design manufacturable products, design feedback control systems, op amps, all that sort of jazz. Yes, all this sort of essential stuff. And I hope that he's left the math out of this. Anyway, Barry is a principal design engineer at Datron World Communications. He has taught circuit analysis at San Diego State University, servo systems for the IEEE and numerous industrial seminars. Holds 8 patents, but I won't hold that against you. And Bazza, as I'll call him, is from Carlsbad in California. I've been to Carlsbad. Hi to all my viewers from Carlsbad. And there he is. Good on you, Barry. Legend. And about the reviewers of the book, John Bernardi, there you go, and Joshua Dahl, let's zoom out a bit, Bruno Palliard, if I'm pronouncing it correctly, notes to instructors, and we're straight in, like Flynn, how to design resistive circuits. Here we go. Oh yeah, Thevenin sources, all the good stuff, design of a decoupling circuit. Yeah, we're straight into it. Look at this, decoupling into op amps and bias in. Design of pi attenuators. I won't show you the whole book. Then you won't want to buy it. How to prevent a power transistor from overheating, chapter 2. Beauty. Alright, starts out with a thermal model here and then goes straight into, and I like this part actually, using manufacturer's data for thermal analysis. And then it shows you typical data sheet figures and then how to design thermal stuff. Oh, and there's the heatsink. It's wonderful. And then how to analyze a circuit. We've got ourselves some MATLAB code for you fans out there. Oh, and it just gets better. How to use statistics to ensure a manufacturable design. Awesome. And how to procure a custom component, and then goes into all the manufacturing stuff on that and the bell curves and everything else. Oh, this is really good. The chapters are only short in these things, but they seem to be to the point and have some nice info. Not an absolutely complete book, I don't think, but geez, there's some handy stuff in here. Oh, second order control system design. Oh, it's getting meaty. And it's got op-amp noise stuff and all sorts of things. Yeah, lots of traps for young players, capacitive loading, looks good. But once again, a pretty short chapter, but yeah, there's some useful stuff. And the final chapter, getting your job, keeping your job, and enjoying your job. Beauty. So Bazza says that this book is for graduates and people going for their first job, or for seasoned people who just want to refresher on what he thinks are the basic topics that you might typically encounter in your first year on the job designing electronics systems, or you might get at job interviews and things like that. So he's selected his things: basic resistive circuits, basic how like stuff, overheating, power transistors, things like power, thermal stuff, how to analyze circuits, transfer functions, and statistics is a big one. Totally agree. Feedback control systems, excellent. Basic op-amp stuff, analog filters you got to do, how to design digital filters, how to work with RF signals, and enjoying and keeping your job. So it's a fairly eclectic mix of things, but ones that Bazza personally thinks are the go. And, well, I don't disagree at all. This looks like an excellent book. I recommend it. So thank you very much, Bazza. That one's a ripper. I'll include a link down below to the Amazon store where you can buy it. I think it's about $40 or something like that. But bloody Amazon. The Kindle version is only like a couple of bucks cheaper. Are you kidding me? Grr. Anyway, good on you, Bazza. Next up, we got one from an Aussie, Scotty Brown. G'day, Scotty. He's a Queenslander. Bloody Queenslanders. We beat you this year, by the way. Absolutely thrashed your ass, New South Wales did. Anyway, let's check this sucker out. I'm really liking this sucker. This is a Bobby Dazzler, it really is. Look at this. And it can even slice bananas as well. Bloody ripper. Geez, that was a good banana. Let's have a look at Scotty sent us. Whoa, what is that? It's like a transistor radio. Awesome. Pure Evoke Flow. No, it's got like a LCD and stuff on it. Fancy pantsy. Let's read the note. Hi Dave, this radio was given to me by a friend with a busted LCD. It supposedly has already been repaired once but failed again. Looking at the specs online, it's supposed to do both digital and Wi-Fi internet radio. Aha, thought you might look at it for a teardown or fix to add some tunes to the lab. Awesome. Cool. Thank you very much. Well, it actually looks pretty jazzy, and it's got some 10-term knobs here. I've powered it up, and we do have a... it's got a... well... no, it's gone into standby. And it's designed in the UK, manufactured in China, but it's this snooze handle. Okay, okay, so, right, got it, there it is. Look, snooze handle, so you can just touch that. So obviously it's a capacitive touch sensor, so you can just hit the snooze handle like that. It's got an alarm on it, but that is pretty good. I've wanted one of these Wi-Fi radios for the lab, actually. I don't have one, but... shame the LCD doesn't work. Maybe we can fix it. Let's do a quick teardown. There it is. It's got an aerial beauty, and looks like it has room for a battery pack. Yeah, it's obviously like a lithium, probably a lithium rechargeable pack or something like that. And your requisite stuff there, and it's a ported enclosure here. And, well, yeah, a few screws on the back. Let's go. All right, let's see if we can use the antenna there to... there we go. Hey, look at that. Hey, some decent shielding on that. Look at that tape around there and all that shielding. That's actually quite substantial. And they've got, look at the foil shielding they've got on the ribbon there going to the capacitive touch front panel, and ribbon going over to the LCD. Yeah, it looks like somebody's had a hack on that LCD. So now, is it just me, or is there something wrong with that power out there? It's just not sitting quite flush with that heatsink on the back of it. Not that great. Yeah, well, yeah, you're going to need a lot of thermal paste in there to compensate for that, and it's going to be pretty poor. Jeez, that's not great. This PCB is from Imagination Technologies, Pure Digital, 2004. Is it? Was that 2008? I can't see on the screen. 2008, there we go. I need a higher resolution screen. I am getting a higher resolution camera. It should be like in the post today. I'm getting the new Canon HF G30, by the way. I'm shooting this with a HF G10, so I'm upgrading to a new model. Missing function there, but yeah, this is like a digital receiver and Wi-Fi thing. I'm not going to obviously go in, and this is not a full teardown, so I'm not going to go in there and desolder all those cans and stuff like that. But yeah, I do like the shielding. Plus, they've added a ferrite on there as well. Beauty. And there's your Wi-Fi antenna. That's going to be reasonably effective. There's not much to Wi-Fi antennas, really, and they're rather interesting theory on how they work. They've sort of, anchored it right up here, sort of put it away from the metalwork heatsink, so that should perform fairly well. Nice, fairly thick MDF case on the thing. Pretty good. And there's a little PCB going up to your snooze handle there. There you go, wire just running off. So yeah, it's just a capacitive touch thing. And check out that LCD board. Somebody's really had a good hack and slash along here. What the hell's going on down there? And they've taped it all down. So yeah, no wonder. I mean, I'm not sure what's failed. It looks like a little daughter driver board mounted onto the main board. Vivaldi shaft encoder mod PCB, pure digital, blah, blah, blah. Okay, well, these are the, by the way, the main board is the rotary encoder, hence the, yeah, there it is, Vivaldi shaft encoder PCB, and then they've got this little LCD driver board on top, and yeah, geez, your money's got to be on that connector. Oh yeah, look at that. Somebody's soldered and repaired that flat flex connector. Oh goodness, so there's nothing, nothing's blown. The LCD probably isn't blown, but something's gone wrong with that flat flexes, which is really unusual. It's almost as if like it's been cut or something like that. I'm not sure, but geez, I don't know. Anyway, we have a part number there with the RIT display. Maybe you can just buy a new one instead of dicking around patching that. Ugh. So thanks, Scotty. I'm actually gonna I'm very interested to actually try and fix this thing, because I think I can make good use of this sucker. So yeah, I'm gonna have a shot at that. Maybe I'll do that as a separate video. And the really good thing about a battery compartment like this, fully sealed effectively, is it's a good place to put your screws when you've got a work in progress. Beauty. And next up, we've got one from Christopher Silcox, if I'm pronouncing that one correctly. He's from Duluth, in the United States of America. So let's crack this one open and see what we have inside here. Is that going to do the business? Maybe not. No. Oh, look at this. Man, hang on. How do these boxes open? Pain in the ass. Should just slice the whole damn thing. Ah, there we go. Alright. Here we go. We have... ta-da! It's a HP Jet Direct card. Awesome. I needed one of these for my dumpster dive printer, which I got. So thank you very much. I'm going to whack that in. It's a 10100 Ethernet card basically, and it just slips right in the back of the printer. Beauty. I needed that sucker, so thank you very much. And Chris has also included in the note, ta-da, $10. Awesome. None of that US funny money business. This is a genuine Aussie polymer note. Beauty. Awesome. Thank you very much. I'll get something saving nice with that. And next up, we have a pretty big post pack here from Stefan Keybooms. Jeez, why can't everyone just be called Bruce? Anyway, for those who know your Monty Python, he's from Poway in California, USA. So thank you very much. All it says is really old electronics. Oh, we love really old electronics. Can you smell it through the pack? Nah. Anyway, let's whip this sucker open. Oh, shouldn't have done that. Should have known. It's that horrible bloody cushioned shit. Oh, hang on. No. Yeah, fail. Pull tab to open. Unbelievable. Anyway, let's have a look here. Inside a FedEx package. So, they're evil. The stuff's everywhere. Anyway, really old electronics. Ho ho! Woo! What is that? Oh! Wow! Memory board. Ha ha! Yes, it's a memory module, a whopping 400 words / bytes of memory. It's a ferrite core memory, presumably for a Siemens mainframe, manufactured in 1970 and was still in diapers at the time. Wow, thank you very much, Stefan. Let's take a look. Wow, that is fascinating. A big plastic enclosure like that with a couple of dual row backplane connector to plug into the system. I'm surprised it doesn't have like a handle on the thing actually to move it in and out, and it's double-sided. Yes. Oh, look at the density. Presumably 200 words per side. So 100 words, 200 words, 300 words, and 400 words ferrite core memory. And yes, there it is. Look, 30th of the 8th, 1970. Goodness. Now, if you don't know how these magnetic core or ferrite core memories actually work, I'll get the macro lens out and try and get a real close-up on these. I'll link in the Wikipedia page down below. It's quite comprehensive, so I won't go through a huge amount of detail on it, but suffice it to say that there's a little ferrite ring on each one of those bits, and each ferrite ring is it's all woven through with all these wires, and they can store an individual bit, a 1 or a 0, in each one of those little ferrites in there. So there's like thousands of ferrites in this thing. Fantastic, all woven with the wires, as we'll see when we get the macro lens close up. But the thing about these is that when you read out the data, you would actually destroy the data. Go figure, it's actually destructive memory. Unbelievable. Anyway, let's take a close-up look at the little ferrite rings in there. There we go. Check that out. You can see these tiny little ferrite cores and all woven in this intricate matrix. I would love to see a video of them assembling these. I think there is an old video, like as part of one of the NASA the Apollo computers or something, winding these memories and the elaborate machines that actually do it. And I'll have to dig that one out. Somebody will link it in, no doubt. But there you go. Each one of those little ferrite rings can store 1 bit of information, and if you read out the data, you destroy it. Unbelievable. And I think that's a 4x4 arrangement in a coincident weave, current arrangement, as they call it, or something like that. And to store each bit, they put a little pulse through, and you can magnetize each individual ferrite bit. Awesome. And there'd basically be an XY grid on this thing, as you'd expect, and also a third sense line and an inhibit line as well. And you would put a pulse on the XY lines, and you would either get or not get a value out of the sense line, depending on whether it was a 1 or a 0. But as I said, actually putting that pulse in could actually be destructive to the bit itself. And I bet you it's next to impossible to get data on what these devices are for the rows and columns. Oh, not a chance. And just look at the crusty flux residue on this. You would think that this thing's been reworked or something, but no, that's the factory soldering. Oh, goodness. Alright, I'm on my Tagano microscope here, so let's have a look at this puppy. We can zoom in on this and get a pretty good look at this ferrite core memory. Look at that. That's as close as I can get. But there you go, you can see that there's 4 wires travelling through each one. So these are all enamel coated wires, of course, and the green one there is going to be the sense wire, and you see how they just all loop through and wound around, and yeah, it's all a bit how you're doing, but it's quite an effort to get these through, because these are absolutely tiny, these things, And so green one is your sense wire, and then you've got your X and your Y wire running through, and then the fourth one is going to be your inhibit line. So there you go. That is a nice little close-up of some magnetic core memory. Love it. And we'll can zoom right back out on that and see how they're just all wired through in that arrangement. So, geez, just imagine doing that. They've got to have some sort of automated way to do it. And then, of course, then you've got these lines actually going through. I can touch those. Look at that. Ta-da! And that is just beautiful. Thing of beauty, it really is. And that is 100 words of memory, I think. However big a word there is, I don't know. Somebody want to count it? Go for it. And just as a very quick comparison between old and new, look at this. 1970 magnetic core memory technology. We're looking at about 100 bits stored in those magnetic ferrite rings. There's about 100 of them fitting the same space as a modern micro SD card. Look at that. This one's only a paltry 2 gigabytes card, but we're talking just even if it's 2 gigabytes, we're talking 160 million times the amount of information. Unbelievable. So basically what you'd have is just your X and your Y drivers here and a sense line going through there, and then you would apply a current pulse to whichever location you actually wanted to on this thing, and then you could sense the data back on the sense line, and you could set or reset a 1 or a 0 in each one of those little ferrite rings. Absolutely fascinating. And the access speed or something like this around about a microsecond or something like that. So basically 1 megahertz RAM we're looking at here, probably maybe a bit slower, maybe a bit faster, we're not sure. So thank you very much, Stefan. I've always actually wanted one of these for the lab. I should frame it or something like that, because it is fantastic. But before I do that, I will probably, if I get time, do a video on this, actually powering up this and actually writing data to it and see, well, it should still work. It's just a bit of ferrite and some wires. I have no idea about these driver chips over here, but we can easily just tap in. I mean, easily just wire in and bypass those, and we probably should be able to store some data in here. So if you got any good ideas for doing that, please leave it in the comments. So thank you very much, Stefan, and that's probably all for today's mailbag. Not a huge number of items. I've still got a whole bunch left, but this has probably gone long enough anyway. And well, I don't want to blow all my mailbag wad in one go. Catch you next time.